Good afternoon, everyone, and thanks for joining our webinar. We're going to take a few minutes here and just give everyone just a couple extra minutes to make sure that they can sign in and arrive, just in case they haven't had the chance to jump on. We'll get started in a few minutes here. All right, let's kick things off now. Hello, everyone, and welcome. My name is Doug Iwoodchow, and I'm a Marketing Communications Specialist at Testo North America. We have a great session for you today. Automatic charging with the Testo Smart Scale and Intelligent Valve. To kick things off, we're going to go through a couple of logistical matters. Our session today will run roughly 1 hour. We will have all attendees muted, but we will encourage you to submit questions at the end. Submit questions into the question panel, and we will have them answered at the end. We are recording the session today, and we will send you the recording of the webinar afterwards by email. As a reminder, all attendees of today's webinar will be entered to win a brand new Testo 560i Smart Scale and Intelligent Valve Kit. The winner will be selected at random and contacted through email. Now I'll go over a brief description of Testo's services and what we offer. For over 65 years, Testo has stood for innovative measuring solutions. Testo helps over 1 million customers worldwide save time and resources, protect the environment, ensure quality, meet regulatory expectations, and increase the value of their goods and services. Testo is a major supplier of monitoring instruments for markets as diverse as chemical, food service and production, pharmaceutical and biotechnology, as well as commercial and residential HVAC suppliers. Today's speaker is Aaron Longacre. Aaron is the product manager for instrumentation at Testo North America. He has over 10 years of mechanical contracting experience, in addition to 10 years of pharmaceutical supply chain project management. After joining Testo, Aaron manages Testo's diverse instrumentation profile in HVAC, combustion, electrical, indoor air quality, thermal imaging, food, and pharmaceuticals. Aaron is a graduate from Albright College with a Bachelor of Science in Business Marketing and a Master's in Business from the University of Phoenix. He currently resides in the Westchester, Pennsylvania area and enjoys camping outdoors, hiking, and various adventure sports, as well as spending time with his 2 children. And with that, I'm going to turn things over to Aaron.
Great, thank you, Doug. Appreciate it. Hello, everyone, and thank you for joining today. Let me go ahead and jump into the next slide here. So, with the way that the landscape is changing, especially as the old is becoming new again, our vision of the efficient technician is also changing as well. In the past couple of years, we've released the new 550S and 557S digital manifolds. We've also been expanding that portfolio with Smart Probes, and also with the 560i Smart Scale and Intelligent Valve. But what we have been able to do is we are trying to make sure that as the demands of the job are changing, we want to be right there with you. So easier and faster to use ever before. From the old manifold to the new manifold, we have the larger display with the dot matrix technology that can show more values and create graphing, as we've noticed with the newer manifolds. We also have improved operating concept, fewer buttons, and both intuitive functions as well. And then the refrigerant favorites, we now have multiple refrigerants that are available. And as we've been seeing, the landscape of refrigerants has been evolving, such as A2Ls and soon A3 refrigerants as well will soon be coming along as well. So being able to have that flexibility, having manifolds and refrigeration equipment being able to handle these different ones, especially with the environment changes, so on and so forth, we have that. These have been built tighter and sturdier, and they're also compact. One nice thing is if you do have a 550S or a 557S, you can hold that in your hand and it feels like a solid piece of equipment that you can use and you can depend on. Truly smarter than ever before. Consistent connectivity, direct and easy connection to the smart probes, and as well as up to a 450 feet range of direct range with the Bluetooth, with the wireless vacuum measurements with the 552i smart probe, the new app that works with all the Bluetooth devices, and as well as the endless possibilities with the platform that Testo has been pushing for the last couple years now, is being able to expand your toolkit with programs and other tools with our Agile platform. So with the scale being released, as well as many other tools that are going to be coming to a supplier near you, let's jump right into it. So with the 560i scale, no joke, this is the only smart charging system in the world, and not by just weight, because there are ones that are available for weight, but being able to charge a system with the values that we use on a daily basis, such as superheat and subcooling and target superheat. So to give a little overview, there's a smart algorithm to charge an AC unit with 4 different modes. You have weight, superheat, subcooling, and target superheat, all important values that we need in our daily jobs. This is easier and faster to use than ever before. Connects with the manifold as well as the Testo smart app. So this can be controlled either with just the app or with the manifold, or all together. It automatically connects. As you're familiar with any Testo product, they automatically connect up to the Testo smart app as well as the digital manifolds as well, and even the second generation 550 and 557 manifolds that have Bluetooth capability. And this works up to 165 feet with the valve and 100 feet with the scale. Again, line of sight. 550S and 557 with the second screen can go up to 400 feet. Again, line of sight. The scale is built very sturdy as a metal housing. It is IP44 rated, and the valve is IP54 rating. So the valve and the scale are very solid. They can withstand getting splashed on, wet, which we understand in our profession that they are going to get splashed, they're going to get wet. Some days we're working out in the rain, and some days we're working out in the heat. So we understand what we need to do. The handle is to able to hold and carry the devices, and the platform is optimized to hold up to bottle sizes, canister sizes, up to 220 pounds. So with that star design, it is very sturdy. There is a specification that we do have for having the degree of tilt on that to make sure that the scale is within its operating specification to operate with that great accuracy that comes with Testo. So what we're going to do first, before we actually jump into the scale, let's go over a couple little things on the basics of refrigerant and a couple little excerpts that we also do with our NATE trainings as well. What I want to try to cover is some basics of refrigeration and then jump into the scale a little further on how to use it and to kind of go over some of the main points of it. So when we look at heat transfer, the laws of refrigeration, we understand that fluids absorb heat while changing from a liquid to a vapor state. Fluids give up heat while changing from vapor to a liquid. And this is understanding when we've got our saturation temperatures, which we need to think about, when we've got everything going between the condenser to the evaporator, to all the different coils that we have from an indoor and outdoor unit, whether you're working on a heat pump, whether you're working on a mini split, there's always the different changes going on. The temperature at which a change of state occurs is constant during the change, providing pressure remains constant. So we know that our refrigerants have different pressures, they have different temperatures. that the blends that are effectively getting pumped through the system by the compressor and making sure that heat exchange can take place is we're always making sure as technicians that we are watching that, as those are some of the most important factors when it comes to charging a system. And then heat will always travel from hot to cold, and absolute zero, we know that's really tough. So, is it even possible? So taking a look at a compressor, reason why I brought a compressor up is this is a very important piece of the whole refrigeration cycle. So the vapor to gas compression pump, which uses pistons and other methods to compress the refrigerant gas on its way to the condenser, is being realized. We all are familiar with it. We know when we fill a system, in the past, you would always run the risk of, we never knew how much was actually in a system. What we'd always want to do is try to evacuate everything from the system and making sure that we can put in refrigerant as well too. So if you're ever unsure, you always want to take it out. The biggest risk you could run into is not knowing how much is in there and flooding that compressor, which if we flood that compressor, chances are things will not work as they should. So some quick definitions here. What is superheat, subcooling, and saturation? Superheat is the temperature of vapor above its saturation temperature given at a given pressure. Subcooling is the temperature of a liquid below its saturation temperature at a given pressure. And that saturation point, kind of one of the most important pieces is to understand, especially in the environments that you're in. And that saturation point is very key. And this will also make a little bit more sense as we go into the actual scale and some of the functionality and why it's so important to be able to charge with different values to make sure that you have efficiency based on the location you're in. But the saturation point is the temperature at a given pressure at which a refrigerant can no longer absorb or lose heat without a change of state. Now we're going to look at why is superheat and subcooling important. So superheat is a condition where the refrigerant vapor gas is well above its normal evaporation point temperature, keeping it from condensing and therefore change from vapor to a liquid, so that no liquid enters the compressor. Remember that superheated refrigerant contains no liquid. Again, very important to make sure that we understand how these compressors are designed, how they work. They're designed to only pump vapors. We understand if we flood a compressor, we know that's usually not good. We also do know that compressors also do run, that they do take some of the oils that are let off by those refrigerants to help lubricate those parts that are in there. Subcooling is the condition where the liquid refrigerant temperature is well below its normal boiling point temperature, keeping it from boiling and therefore changes from a liquid to a gas, so that only a solid column of liquid refrigerant enters the metering device. And we want to remember that subcool refrigerant contains no vapor. And what we mean by metering devices, we have a TXV, EXV, etc. These must have a solid column of liquid to operate correctly. And again, we also know that different systems, also from a superheat perspective, operate on a fixed or known as a fixed valve or a piston type system where it just opens and closes. And then the TXV valve is the metering valve, which is more of your subcooling applications. So just giving an overall basics of refrigeration charging and the 560i, especially going into using this device. You always want to make sure that you're reviewing your manufacturer specifications for proper guidance. What type of system is, the tonnage, the BTUs, also understanding what kind of refrigerant this system has. We still see the days of very few R22 systems. Occasionally you might see an R12. Now you've got 410A, and soon, what do we have next? R54B. Again, all these refrigerants are going to be changing as we're going along here. So you always want to make sure you're double checking what type of system and what kind of weight that system has been charged with. Rule of thumb is we know that usually a system may have roughly 15 to 20 feet worth of line set that you can add between your outdoor to your indoor of refrigerant into that outdoor. So you always want to make sure that if you need to add more, you know exactly by doing your calculations. Always be aware of your ambient surroundings, your temperature, your pressure, your humidity. As someone that lives in the Northeast, if you're farther up in the north, you may be having different ways that your pressure is going to be working, your humidity, also your temperatures, as compared to someone in the south. Someone that's going to have hotter temperatures, more humidity. Someone that lives at sea level compared to the mountains. The pressure will also affect how a system operates as well too. We always want to keep in mind that a lot of these systems are developed in ambient conditioned warehouses. And yes, they do test them in the elements because obviously they have to stand up to those things. But you also want to make sure that these systems operate in harsh conditions, whether it's constant sun, constant rain, constant cold temperatures, constant hot temperatures. It's going to vary for wherever the region is. And before you do any kind of charging with refrigerants in a system, you always want to make sure you're inspecting the system. Always ensure the coils and the filter are clean. Right now, I'm sure a lot of businesses, a lot of technicians that are on here, you're probably in the middle of cleaning service season. There's specials that you're running to make sure that you can go clean the system up, make sure that your pressures and temperatures are running accurately, and making sure that everything else is clean so that the summertime works. Same with the fall time, you're going to do the same thing for heat pumps, making sure that the coils are clean, make sure the filters are set. You also want to make sure that there are no leaks as well too, whether it's your joints, your valve joints, your service valves, your TXV, for example, making sure that that's solid and tight. Piston or TXVs are also working in order. You always want to make sure that those are working as they should, because from in the past, from what I remember, TXVs used to be a #1 service item on a system that would get replaced, or whether you had a hole in the coil, or whether you had a control board or a back capacitor. Those are all different things that would go on. But again, the biggest thing is always before you charge, you want to make sure that you understand the system, you want to understand your ambient surroundings, and you want to inspect that system to make sure before we go dumping in refrigerant, because we know as technicians, we know the cost of refrigerants are rising, and we know our customers are also going to not be happy sometimes if you have to put refrigerant in a system when it doesn't need it. So always make sure that you're doing inspection checks. And of course, we always want to make sure that we also read the instruction manual of any tools we use as well. I know that's a tough thing, but you always want to make sure you take that time to check out your manuals as well too, so that you understand exactly how these work. So with the 560i, what exactly does it work with? So it works with our 550S and our 557 digital manifolds. It also works with our Testo 550i, the manifold with no screen, the one that works as a smart probe, a very light and handy manifold to do some charging, as well as having anything work with your phone. Smart probes, your 115i smart probes, even your 549i's can work with this. The only thing you would need is a charging tee to be able to use this with the scale. And last but not least, the Testo 550 and 557 Bluetooth, or the second generation manifolds as well, with the Testo Smart app. So we were able to develop the scale to work with existing Testo equipment, as well as our latest and greatest Testo equipment as well. And the Testo Smart app, one app for the whole refrigeration family, as well as the expanding Testo portfolio. The Testo Smart app is becoming a very integrated application, almost like your assistant on the job when it comes to data, grabbing data and collecting data, and being able to create those reports right on the spot, being able to talk to your customers and show them the different trends that go on as well. So this app is compatible with all Bluetooth capable Testo measuring instruments for air conditioning refrigeration systems, as well as heat pumps, mini splits, and so on. Avoiding measurement errors easily. There are plenty of measurement menus. There's charging by superheat and subcooling, providing the optimal support in configuration and taking of measurements. If you do have the Testo Smart app, which actually in the bottom right-hand corner is the QR code to take you to the app. So if you do not have it as of now, please go ahead and take the time to download it while I'm going through this. And you can take a look at exactly what this application has and where the different tools will be able to plug in, so on and so forth. You can evaluate your results fast. The values are presented clearly. You can get them in a tabular form. You can get them in a graphic. You can actually see the swings and everything from a graph. You can do short-term data logging with the manifolds as well. You can also, as you're charging a system, you can see how the system changes as it goes, as you're putting refrigerant in. So this is another nice feature with having the app, to be able to see analytically what the system is doing and what the swings are doing at that time. You can create reports on site. I know I did mention this and email this immediately, but these digital measurement reports, including photos as PDF and CSV files, are great to put with customer records, especially those that are doing billing right on the spot, that when you do your service, put the bill together, email it, as well as putting the results with it, gives you that backup as to, hey, here's what I did, here's what I went through. We talked about this, we talked about that, here's the recommendations. Here you go, Mr. Customer, you are set. Synchronization with the Testo data control PC software. This is a free piece of software, as well as the app, which the Testo Smart App is a free app. The data control PC software is free as well. This is where you can actually set up your customer database. You could even take everything you get from the app, go back later when the day is almost done, you're doing your paperwork. You can go and grab these reports, amend these reports, add some more details and information into it, and be able to send that off with the customer as well. You can store your customer data and your sites, and also do much more with the data control app. And as I mentioned, this is free for iOS and Android. And again, before I go to the next screen here, please take a chance to download the Testo Smart App. And briefly, if you are still on the Testo Smart Probes app, please note that that app is officially sunset, and now the Testo Smart App is the new one. Here's a little overview of the data control software. Just to give you an idea, it looks very similar to the actual Smart app. It has a nice, clean user interface that's very simple for setting up your customers, setting up the sites, and being able to download that to your Smart app so that you have your customer records there at all times. Graphic display, so you can export graphs, manage customer profiles and measuring points. This is all done via Wi-Fi, which is actually a really neat feature. The way to do this is, if you have your Smart app on, there's a specific setting that you go into the network, you get a network key, punch that into your data control software, and as long as your computer and your mobile device are on the same network, it will then seamlessly connect and share that data between the PC software and the Smart app. Maximize the efficiency by creating several measurement reports at once. So if you've done, say for example, you were checking superheat and subcooling on a system, you had a charge, and you're also taking your splits of your indoor and your outdoor, or from your supplier return, or even doing some airflow measurements at your register grills, you could even go ahead and put all this together and give that customer a report that says, hey, Mr. Customer, here's what I did. You are all set to go, and off to the races you go, and on to the next job. And then finding the measurement data easily, filter and sort your measurements out, and assign measuring points. So now taking a look at the scale, just to kind of get an idea for those that are maybe on the fence of purchasing the scale and the valve, here's your opportunity to kind of get a good look of it, what it looks like over this webinar here. So the rubber surface is for optimal stand of the refrigerant bottle. It is grippy, so we'll make sure that nothing will slide off. It is a low profile so that you can actually get the cylinder up if it is a heavy cylinder. The metal housing on the top and the bottom side are solid. If you actually hit your fingers on it, you can hear it. The dust blocker assists with the measuring accuracy, so making sure that no dust is getting up in there, because we are working in grass, dust, dirt, stones. Every sort of environmental factor was taken into consideration with this. So we want to make sure that the scale part, the weight within the scale, that we're making sure that we are actually getting the weight, is not being obstructed. And it also works with uneven ground, and there is a specification for that. Now about the refrigerant, the intelligent valve, there is a hook that is changeable, that you can actually go for the magnetic hook, which is already available with our 550S and 557S manifold. The on-off button is actually has a neat little hidden feature that some do know about. It is also in our manual, and I'm going to actually take the time here to kind of explain this. So that button is not necessarily just an on-off button, which is its main function. What you are able to do when you have a system connected up, so once you have your manifold hooked up, you've got your refrigerant can hooked up, you've got the scale hooked up, all your lines are all set. You can actually hit the button 3 times, and that is 1 click, 1, 2, 3. You hit it 3 times, and you're going to hear the valve open, and that valve will open for 1 second. That feature was designed to make sure that we are able to purge the hoses, because the one rule of any kind of refrigeration system, and hence why we evacuate a system, and hence why 500 microns is the way we want to get to. We want to make sure that system is clean. We don't want air being introduced into that system, because you want to have that clean and clear vacuum. So this is one way that you are actually able to purge your lines from the from up into the valve into your manifold, or whichever manifold you're using, and then obviously the lines going into your refrigeration circuit as well. This might take you a couple times to do it, so you might have to hit it 3 times, a couple times, just to make sure you get refrigerant at the end, and you can see it by just kind of cracking open the valve to get a little bit to pop out. So as long as you push that air out, get some liquid in there to make sure that they are completely clear, then you should be set to go. There are 2 LEDs, one for the connection status, one is to show if the valve is open or closed. Red equals the valve is open. That means it is a caution that this is open, it is working. And when it is in green state, that means it is closed. The caps that are on there prevent moisture entering the valve. And this is a one-way valve. This is an in to the out. So if you notice, there is an arrow on the valve. It goes from left to right. And I will totally tell anyone, please do not recover with the valve. It does not work it does not work in the reverse direction. So this is a one-way into out valve. So now some of the features. We did cover the purging feature by pressing the on-off button 3 times to open the valve to allow refrigerant to flow into the hoses before charging. You can also use it at the end. So if you have a little bit of or you have a little bit left in the hoses at the end, you can make sure you purge that back into the system from the canister line, from where your bottle is, into the manifold. Make sure that you turn the bottle off, purge the rest of that out into the actual manifold, and then you can connect that and then get your lines purged as well too, to make sure that refrigerant is back in. Or if you keep whatever the refrigerant is that you're using in your lines, that is okay as well too. That is generally some of the practices that we have seen. Pulse charging, there's a pulse charging feature, which is the automatic fill by weight. This controls the charge by opening and closing the valve to allow for bursts of refrigerant to be pushed in. If you remember the beginning of the presentation, we talked about a compressor, and flooding a compressor is bad. If you're running a system and you're putting in by weight, the pulsing feature allows that valve to put in little bits at a time, so that you're not completely flooding that compressor, so that exchange can happen with the system. The maximum factory weight. This is another feature of added protection to prevent overcharging. This is available on Superheat and Subcooling, as well as the Target Superheat applications. This feature allows you to make sure that you can understand what the factory weight is. So the unit might say 5 pounds. I'm going to go ahead and put 5 pounds so that it stops at a certain interval to make sure that we are not overcharging the system. This is also allowing the values to make sure they are achieved, because we do need to give this some time, which the valve and the algorithm do have time built into them, especially when it comes to superheat and subcooling, which we'll cover here very shortly. The superheat range works between 45 and 5 degrees Fahrenheit. The subcooling maximum reaches 20 degrees Fahrenheit, which we will cover this very shortly as to a reason why these ranges are very important. Pause and stop feature, you're able to pause mid-charge to adjust if you need to go a little more, or if you need to give it some more time to kind of let it do its thing. This can all be done via the manifold or the app. Or you can completely stop it if you've hit where you need to go so that no more refrigerant goes in. You can do that if you've hit the value as to where you want to be. The optimized charge allows the user to change the charging program. So for example, say you have a system that's really low on refrigerant, you're not getting a subcooling, you're getting an XXX on your subcooling. What you might have to do is put in maybe half a pound or a pound to be able to start getting a reading of subcooling so that the subcooling feature can be used. And again, we'll hit that here in a little bit. Once you have that weight, then you can then go into your other programs to use that. So just a quick review of the screen. Those that are familiar with the 557S, we know that the screen has the 4 buttons that are able to select up and down, turn the manifold on and off, as well as getting the light. But where this is located is in your measuring modes. So where you have your superheat and subcooling, you have your evacuation, your leak test, your target superheat, as well as your pressure test and your delta T test as well too. That's all within the measuring mode. Your settings are here so that you can set your settings up to whatever you feel necessary that we use. And as you can see in the bottom screen, the refrigerant filling is exactly where this measurement program takes over. So once you go into the refrigerant filling, you've got your 4 modes. This will be able to show the weight, which is you can use your manual. So if you do purchase the scale on its own, you can actually do the traditional way of filling, which is using your scale. It actually has, it will show you the weight of where you're at. You can zero out your scale, go ahead and use your manifold to meter in the charge however you like to do. With the valve, you can charge by weight, charge by subcooling, and charge by superheat. Within superheat, you have the option of using live target superheat. So we understand target superheat. There is a calculation that goes on with superheat. This takes into account your return air wet bulb as well as your outdoor ambient. If we're familiar with the 15 to 20 degree split methodology, this is where you would introduce 2 605i thermal hygrometers from Testo are needed to use this. Whether it's 1 or 2, but this is where you would need this. For this mode, the current outdoor dry bulb and the indoor wet bulb must be measured to be able to get your target superheat to where you need. And again, this works on more of a fixed piston system. So just to give you a little overview of when it comes to show weight, the manual fill and recovery, this is where you can actually use recovery as well too. The manual fill, you can see what the screen will look like with your condensate temperatures, the evaporation temperatures, as well as your high and low side. You also have your superheat and subcooling as long as you're using 115i temperature clamps or the wired temp clamps, the NTC clamps. This is where you'll get your subcooling and superheat, but this is where you can actually use the scale as the traditional way. So there's no need for the valve, and it can be connected to the app or manifold. If both are used, the app acts as a second screen so that you can see it from a distance. So in this mode, the technician only reads the scale values, exactly like the other competitors' products, as well as existing scales. The only difference is you're actually getting this on your manifold so that you can look in one way and don't have to keep looking at multiple different things as well. Now jumping into the auto charge by weight feature. So when you go into this feature, you're going to go into a configuration screen. It will show you where your low and your high sides are at that point in time. And apologize for the metric values here. But the gist is you're able to see kind of what is going on at that time with the system here. You can zero out your pressures if you need to. You can select your refrigerant, which I will always tell somebody, please double check your refrigerants that you know what you're using. That is a common call that we get that, hey, my pressures and temperatures seem to be off. Well, are you on the right refrigerant? Well, no, I'm not. So sometimes that has an impact because a lot of the things that we're using is an analytical base, and we're having those different profiles built in so that we have the right pressures and temperatures that are being realized. As you can see, I'll highlight here the pulse charging. You can select this on or off. The best time to use the pulse charging is when you're charging automatically by weight on a system that is on. If you're doing a new commissioning and you have to add in, say, 3 pounds of refrigerant, you know you might need a little more, you might turn that pulse charge off because you can just go ahead and dump in that refrigerant, no problem, and let it go in without the system running so that you are protecting the compressor. You can also see that the valve and scale are connected. We'll also give you the battery. It'll tell you what the current weight is. And then you can go ahead at this point, set your target charging weight. And again, once you do configure it, this is what the screen will look like. You'll have your scale, how much it weighs now, how much, which is a status bar that will fill. And my target right here is to the right. And you will see this as you go once you hit the start button. As for auto charge by subcooling, so in this mode, you will need the 560i scale, the valve, 2 115i temperature clamps. The scale and the valve can be connected to the app or manifold if both are used, and the app acts as the second screen, which will be similar to every application here within the refrigeration portfolio of Testo. But in this mode, the technician is going to specify a subcooling value, which we can see over here to the top left up in this screen. If you're low in your high pressures, you have a refrigeration set, and you also have your value of your subcooling where it is at currently. You can see the max charge. So this is where that we might want to punch in that number of, for example, if this system takes, or a factory charge is 4.8 pounds that it takes, we might want to put in this value just to be safe that we don't go and overcharge this. And you want to always have that. Again, if you need, it will always ask for this value. If you need to set it up, then you can definitely set it up a little bit more. But again, that is more of a safety feature put into what you will need. And again, you can always optimize your charge. You can always add a little bit more in as you got to go. It will always work off of that value. And then down below, your subcooling target. This is where that you will be able to put in what you're looking to get. So this system right now is reading 5.4 degrees Fahrenheit on a subcool. We might want to get this up to 10 is what the manual is saying. So we might have to put in just a little refrigerant so we can set that target, accept it, and then we get into our starting subcool where we're at. And here's where our target that we want to hit. And then once we hit start, you will make sure that you can see the status as it's going. It'll tell you how much it puts in. The subcooling algorithm does put in a little bit of charge. It gives it a brief pause. It waits a little bit to see how the system stabilizes, because we do need to give these things time for let them stabilize. And as it's going, we want to make sure that we're, we can kind of set it, forget it, and then once it hits its target, that will come back, double check. Do we need to add a little more? Yes or no? We can make that determination once we get to that point. I will say on this screen, the one piece I do want to highlight, because this is another call that we get as well too. Why is my subcooling reading XXX? Well, that could mean a couple different things here. One, you don't have a subcooling value, so being able to use the subcooling function, you would actually have to make sure you put in a little bit of weight. So you want to make sure you do have a subcooling value, because the algorithm does need some sort of value. So you might be low on charge, or you might have another issue that is going on here. So ensuring that you have a value before you start using the subcooling program is very important. Same with superheat. You want to make sure within a specific range. We know that we have that 45 to 5 degree superheat range. That's the other thing as well too. So you always want to make sure that you're within some sort of value, because the algorithm needs the data to be able to do it correctly. So the procedure will go on till we reach your subcooling. The pause will sometimes be between 5, 10, 15, 20 minutes. It will automatically kind of take in the timing, see where we are close to that target. And we always want to make sure that, especially from Testo and the algorithm, that we give you enough time to make sure that that system is stabilized. So going into the superheat side of things now, again, the same setup. The only difference is we can set our superheat target by a manual input, as you can see right over here. Same startup, except we're looking on our superheat side. Again, more of the fixed piston systems use the superheat compared to the TXV, which is more of a subcooling side of things. You will still need two 159 temperature clamps, the scale of the valve, and also can be used with the app as well as the manifolds. This is where you can specify, again, you want to make sure it's within that range. We want to at least get it close to there. So the algorithm is going to measure all relevant values. Based on the live readings, the valve will open and close automatically. So as things are changing, which superheat does change a little bit more rapidly compared to subcool, you got to give that a little bit more time. You want to ensure that you are using this and that those values are reacting as they should. You want to see if your pressures are rising a little bit. You want to see where your temperatures are. You want to see where that saturation point is on where exactly you are hitting those temperatures and where this exchange is taking place. So this procedure will continue until you reach the superheat target, and the amount charged will then be documented via the app if you have that connected as well. Also, you can see it here is where you started. It will tell you how much you charged to get to that value, and then you're able to kind of see where it is from where you started, and then you can also charge effectively as you need to. So by adding refrigerant, the superheat value goes down. If your target is above the current value, it will not work and show a notification. I know I have been getting those phone calls. We just want to make sure that we can put those in. We want to make sure we get within those ranges that we specified here in the very beginning. Again, the target superheat, you have the choice. If you do have a fixed piston system, this requires the scale of the valve, the two temp clamps, as well as one or two. I know it says two, but you can get away with one 605i in automatic mode to be able to use the target superheat function. So you have the choice to switch it within the app. On the manifold, you can do this as well too. The most important value is with one 605i, you can get your outdoor ambient for your dry bulb. You can go ahead and get that, punch that into the manifold, go inside, put your 605i on into the return, make sure you have your wet bulb running, and then that will give you that target superheat of exactly where you want to be. Again, this is, you want to have two 605i's. The algorithm will measure all the relevant values based on the live readings. And then this is also making sure you can do the same thing that you do with subcooling, superheat, as well as target superheat and weight. So looking at the compatible devices here, the Testo 550, 557 Bluetooth version, which is the second generation manifold, exactly how these work. You can show the weight, yes, with the app, charged by weight, superheat, subcooling, and live target superheat. Bottom line, this manifold requires the app. You can't do it on the manifold, but with the app, you can use it all together. So those that have 550 and 557 Bluetooth models, you're able to download Testo Smart, use the scale with the 550 and 557 Bluetooth manifolds. Same with smart probes, works the same way. Same with the 550i. They all work with the app. With the smart probes, the 549i's, when you set them up low or high side, if you use a charging T or a Schrader T as it is called, you can connect that up and make sure that you still are getting your pressures, your temperatures, you're still using your 115i's, and that with that charging T, you can go ahead and charge into that system where you're charging where you need to. So that is one way to be able to use smart probes with charging as well. Or having the 550i, it's similar. That one is able to charge because it is a two-way valve block that can be used. With the 550S and the 557S, this is the one you can actually use with the manifold and the app at the same time. This works for all the different modes that we have that are there. And the devices that are needed, the scale, pretty much if you're doing show weight, you don't need the valve. If you want to be able to use the valve, that will work by weight, subcooling, superheat, and target superheat. And then we also listed out here what is needed for the for the probes you need. Sorry, I'm kind of losing here because seeing that nice picture of the dog in the background. So 115i, two of those you'll need. Superheat, subcooling, because those are most important readings you're going to need, especially on your pipes for your superheat, subcooling, and then live target superheat is going to require the 605Is to be used as well. All right, let's go on to the next slide here. Oh, there we go. Oh, a little too far. So in closing, the 560i digital refrigeration scale and intelligent valve is compatible with all refrigerants that work with the digital manifolds. The intelligent valve will work with A2L refrigerants, as will all Testo refrigeration instruments. This is a common thing, especially here in the United States right now, is A2L is the future of refrigerants. There's been a lot of buzz on that, and Testo is ready with those, with our current set of tools. Not to scare anybody, but there actually is a version of A3 refrigerants as well too that obviously want to be on the lookout for those. We still got a little bit of time since A2L is a thing here, but A3 is another one that is coming in as well too. The valve, when it comes to the intelligent valve, is a one-way valve, and I want to make sure that I stress that very importantly is we do not use it for recovery. We do not want refrigerant to go backwards into that valve. There's a specification that goes forward. There is a burst pressure on that, and it handles a lot of PSI that will be able to go through from the can into the system. The system also utilizes limits based on ambient conditions and system responses. As we talked about in the very beginning, I want to make it very clear to make sure that you are always doing your checks as a technician, always reviewing your documentation when you're on site at a customer's house, observing what your temperatures and pressures are, taking into account your environmental conditions, exactly where you're at, where you're located, because one location can be different from another location around the United States. So always make sure that you are testing and checking everything before you start filling the system. And obviously, the other thing you want to make sure is always double checking what the system literature requires. There's many apps that if you have to double check to make sure, hey, the system's not working correctly where I'm at, I can always double check, hey, this is where it needs to be. Let's go ahead and use the scale and the valve to get this where it needs to be for this operating condition. And with that, that is the end of what I have here. So Doug, I will turn it back to you. Doug, are you on mute?
I'm sorry. Yes, I was. Thanks.
There you go.
All right. So thanks, Aaron. That was a very thorough overview. We have a couple times for some Q&A here. I do have 2 questions already in the chat, but if anybody else has any additional questions, now is the time to post them. To start off, does the scale and valve have to be calibrated yearly?
Okay. Very good question. And that is very common with a lot of our products here at Testo. So I'm going to refer to the instruction manual. We do actually have a statement in there that says recalibration once every 12 months is recommended in many applications. Hence, I said recommended. So if you feel that you need it, if you're using the scale a lot, if you're using the valve a lot, it does help to make sure you have it. Get it calibrated if it's used a lot. But again, it's a recommendation from Testo to have it recalibrated once every 12 months or 1 year.
All right, very cool. I see here is the other question is, how do I clean the valve out if it gets dirty?
Okay. So another great question, because we do know that these valves could get dirty. We know you're going to be punching a lot of refrigerants through here, different blends have different chemical makeups, so on and so forth. So again, within the manual that I'll say that it does say it's actually page 40 for those that are interested in where this is actually at. You're not to use any aggressive cleaning agents or solvents. Mild household cleaning agents and soap suds may be used. What we typically recommend, and this is common practice with any manifold, whether it's Testo manifolds, can be analog manifolds or any other one, you always want to use either some compressed air or use some nitrogen to blow out that excess refrigerant and get them clean. Basically, you can, if it is dirty, you can clean that out. Generally, what you want to do is just kind of blow some through there with the valve, click it open 3 times while you got some pressure built up. Make sure whatever gets in there gets blown out the other side, and then you're clear to go. So again, using that purge function that is on the valve, that is one way to go ahead and clear out any kind of debris that is within the valve. With the scale, just use some compressed air to blow, within that dust blocker. If you have any obstructions or any rocks or sticks or anything in there, make sure you try to get those out so that the instruments are being used to their full capability.
Very good, very good. And I think we have time for just one more question here. I do see that there are a couple, and we will have them all answered. Aaron will take his time and individually email everybody with their questions. But the last one here, are the original Generation 1 smart probes A2L rated?
The original smart probes, which would be the Gen 1s, that is a good question. I will have to double check on that, and I'll get back to you on that question.
That's great. I appreciate that, Aaron. And we will include that information as well when we do send out the webinar in our notations. And with that, we are somewhat running out of time today. Aaron, as I said, Aaron will respond to the rest of the questions we have received through email. And this is just a reminder that today's training is part of our 2023 webinar series. If you are looking for more detailed information on our upcoming products, services, or any Testo information in general, just join us on one of our upcoming live webinars. Links to these sessions will be included in the follow-up emails, as well as any additional, if you wanted to sign up for our mailing list, follow us on socials. We also include our webinar information there. And then once again, on behalf of Testo, thank you to everyone attending our session today. And thank you, Aaron, for a great session on automatic charging with the Testo Smart Scale. Thanks, everybody, and have a great day.
Thank you, everyone.